Thank you everyone for attending. My name is Darren Bell. I'm Director of Technical Services at the UK Data Archive. Actually explaining the relationship between the UK Data Service and the archive is probably a subject of another webinar, but essentially I work at the UK Data Archive at the University of Essex. It's interesting, some of the things you've been saying, Pascal, and I think, you know, independently almost, we've reached a number of similar conclusions about different approaches to metadata by slightly different routes. But I think this presentation will be maybe slightly less technical and is an overview of some of the different aspects of data management that need to be considered when you start thinking about cross-disciplinary issues. So the UK Data Archive is a repository that's been around now for over 50 years, and it holds about 8,000 survey data sets, which generally speaking are outputted in SPSS, Stata or Tab, and usually have PDF documentation. So those are curated by a specialist and expert team before they're put up for dissemination. And now at the back end, data is generally held as binary files on Windows folders, and there is essentially a complete separation of the metadata, which itself is held in Microsoft SQL databases. So again, that's kind of reinforcing that theme about separation of data and metadata, which doesn't always lead to good outcomes. All of that curated metadata and data is available on our data catalog on the Discovery website, which is a standard kind of ASP.NET site based with an Umberco content management system. As well as providing static downloads to files, we also provide aging data exploration tools like Nestar. So Nestar is obviously something, along with many other people, we will look to replace within the next year or two. But as a repository, you know, it does what it says on the tin, and it's very much a classical architecture that curates pre-designed data sets and then disseminates them and makes them available for download. So what underpins a lot of the metadata is DDI codebook. Now, some of you will be familiar with DDI codebook, but if you're not, essentially, it's a way of marking up data which gives you the kind of key facts about it, and it's produced in XML. So as you can see from here, it's really a number of things about the data. You know, what's the title, who's the author of the metadata, there might be a copyright statement. So this is all very simple and flat and reasonably straightforward. It doesn't take very long to learn, and many archives, you know, I would say in fact the majority of social science archives still use DDI codebook. It does have some limitations though, as well as a trade-off with it being easy to use in that it does lack expressivity around defining relationships between variables and relationships between the data. So although it does serve its purpose in a classical repository, for what we've had to do for the Smart Meter project, we've had to think a little bit further about what we need to do. So a one slide background to the Smart Energy Research Lab, or SERL as we call it. This is a project that started in 2017 and is running to the end of 22. And essentially, it's a data resource for energy researchers across the UK. What we do is we plug into UK households, whoever has second generation smart meters, and through a long and convoluted network pathway, we actually retrieve the data from those smart meters into the UK Data Archive. And that happens on an overnightly basis with hundreds of thousands of postings, as we call them, coming back from smart meters throughout the UK. This was driven really by the fact that it's actually quite hard for energy researchers to get good quality smart meter data, especially outside of a commercial environment. The big 6 energy companies in the UK do have access to this data, but will charge you quite substantially for that kind of data in a lot of cases. So the project was conceived of and initiated as a way of really getting high quality energy research off the ground. Now, there are a number of challenges around that. Technical, the network itself is very convoluted. Smart meters, if you don't know, communicate by old-fashioned mobile signals. So there are lots of points of failure. But generally speaking, after 2 or 3 years, we've got to the point now where we can ingest this data quite efficiently. The legal barriers, and I'll talk a little bit more about access controls, are always something that is the biggest pain in this kind of project. Now, the technical challenges are not insubstantial, but the legal and regulatory challenges around things like data protection, GDPR, sensitive and disclosive data are also not insubstantial. And financially as well, to join this network, it's a bit like becoming a stockbroker and getting membership of NASDAQ. You know, there are significant costs, upfront costs associated with that. Okay, so the whole point of SERL is to simply gather smart energy metadata. It was also to bring that in line with contextual data. Smart meter readings are pretty boring, dry stuff. They're just a bunch of numbers that will tell you how much gas or electricity is being consumed at a particular time of the day, or 48 times of the day more precisely. To really answer interesting research questions about that, we have to bring in weather data, household survey data, which brings in a socio-economic dimension to this. Also the energy performance certificate data, which for each household, that really defines the efficiency of the thermal cladding or the insulation in the household. So from the start, we had a number of different data models and data sets to deal with. So rather than the kind of static SPSS model, we had to kind of rethink how we were going to approach this. So the next slide is something that looks very simple, is very simplistic by intention, but we've tried to explain a number of times to non-technical people and a diverse audience what we're trying to do here. Now, a traditional repository will stand up a number of pre-designed data sets, if you like. You apply for access in some cases, and then you can download them. But basically, in a crude sense, you get what you're given. But essentially, what we're trying to do with a cross-disciplinary infrastructure is to effectively have and I hesitate to use the phrase because it is becoming old-fashioned already, but a data lake where we effectively break up all of our variables and put those in a large repository. And from that, you as a researcher can pick the things that matter to you and that you're interested in, rather than having to offline join things together, which may or may not be the kind of data that you actually wanted to get at. So, I mean, firming that high-level conceptual idea up a little bit, our current repository looks something like this. So we have static SPSS files, PDF documentation. The metadata goes into proprietary database. The files, or the data rather, goes into proprietary file system. Now, when you go to the website, you will do a search. You will use the metadata to do that. Eventually, you'll arrive at a file that you want to work with. So you will then download that, or alternatively, you'll go off to somewhere like Nestar where you can do some kind of online exploration. But it doesn't feel very unified in the sense that the metadata is completely separated from the data. Okay, so the approach we're taking conceptually is that at the end of the day, you can always break data down atomically, and anyone who's familiar with later developments in DDI will know that the idea of having the datum or the data point at the center of the universe is a key concept of that. So essentially what we're doing is taking data sources and breaking them up into a standard, what we call a graph, which is essentially a network of data points. And this essentially flattens out the data and abstracts the wrappers around the data, you know, which might be files or XML structures. So the idea of a kind of knowledge graph almost of variables was at the heart of how we thought about this from the start. So what this should enable you to do at a conceptual level is go into the graph, pick a number of things that you're interested in, combine those and generate a bespoke data product. And then depending on the sensitivity of that data, you might be able to download it, or if it's more sensitive data, you would backhaul that into a virtual research environment or a remote desktop. Okay, so in terms of the considerations of how we actually go about doing this, Hadoop is something we use at the back end. Now, I'm not going to go into detail about Hadoop, that's another webinar, but essentially that's a suite of different products, a bit like Offices to Excel, Access and Word, etc. So it's a bit of pick and mix, so you don't have to use all of Hadoop, use the bits you want. But in data terms, we use something called HBase, which is a key value type database. and something called HDFS, which is a distributed file system. Now, without going to the technical detail, essentially the whole point of Hadoop is it allows you to scale massively. So you can store literally kind of billions of records on a system like this. And that's the kind of back-end platform, the data storage platform, if you like, that we're using. So it's all very well having a storage layer, but you need to get the data in as well. Now, in a traditional repository, you will, as you ingest data, use a variety of tools to look at an SPSS file and determine the data quality, what needs to be scraped off or split, what needs to be combined with other data sets. We use something called Apache NiFi, which is an open source tool. It's actually called Hortonworks Data Platform within Hadoop, but is the same thing. And this is a declarative way of essentially dragging and dropping on a canvas different processes, as they're called, that allow you to perform lots of different operations in a chain to the data as it comes in. So Smart Meter itself actually hits us as very small XML files, albeit there are tens of thousands of those that hit us per hour. NiFi is something that can scale up to ingest those and essentially turn those ultimately into DDI 3.2, which is where we then put them onto the graph as DDI4 eventually. Okay, so in terms of data models, I think really this slide is just to make the point that traditional repositories and really many other organizations have been based around SQL for a very long time. And there are still many perfectly good and valid use cases for SQL. But in terms of scalability, I think, and in terms of flexibility of querying, I think there are other things out there now. I mean, some of these are quite mature in and of themselves. But of the main kind of database paradigms that are out there, and this is what defines, the main ones we use are something called column family, which is Apache HBase, and a graph, which allows us to define lots of relationships between variables and different parts of the data. Now, column family, without getting into too much technical detail, it effectively allows you to store whatever data comes in to hit you. It means that you don't have to do lots of hard-coded work up front to define your schema. So if some data hits you that's not already defined, you can store it in the database without everyone having to stop what they're doing, redefine the schema and redeploy. So there are lots of different data models out there now. So it is a question of finding the right one for the right use case. It no longer has to be SQL as your default option. So I mentioned before, use something called HBase and also something called Janus Graph. Now this is again an attempt at a non-technical account of what a graph actually looks like. So you would have a very simple table with three pets. Now that will be normally a rectangular structure in SQL. Now the way that you can remodel this in a graph is that you effectively smash up the table, if you like, so all of those individual cells become entities in their own right, and you can start to define relationships between the individual cells. So this is a bit of an abstraction, it can take some time to get your head around, but essentially what it allows you to do at scale is to break up very large tabulations that don't normally scale, and almost like a ferret, you can jump into a particular point in the graph and start to traverse your way around. Okay, so for the Smart Meter logical data model, which is based on DDI4, okay, what we do underneath the hood in the real world is that we essentially maintain literally billions of data points within Janus Graph, which itself sits on an HBase key value store. And for each of these data points, we contextualize them, we assign an instance variable to them and a logical data record. Now, in simple terms, that's effectively assigning a row and column coordinate to a particular data point. Now, building on top of that, we can then say for any particular variable, we can say represented variable is, i.e. if you had age as a variable in two different data sets, the represented variable might have two different representations of that. So age might be greater than 60 or less than 60, or in another representation, it might be less than 10, less than 20, less than 30, and so on. And on top of that, you can also assign conceptual variables, which allow you to assign semantics and start exploring all the different relationships between your variables. Okay, so the most important thing, and I use that phrase with caution, the most important thing to consider when trying to think about how you link data sets and how you make interoperability really work is access. This isn't ignored, but it tends to be understated sometimes. And you do see great, data models and approaches to structural metadata that work on the assumption that the data is open. Now, often the data is not open, and there is a kind of trope that any useful data is generally not open data. I mean, I don't think that's particularly fair, but access is a real blocker to making real-time subsetting and analysis work really efficiently. So access covers a number of aspects. It's not just about the conditions to access a data set. It involves user consent to supply the data, the rights to use that data, licenses. Now, in classical repositories, these systems tend to be unique to each organization. I mean, there are some good frameworks and standards out there. I mean, I'm thinking of the 5 Safes framework, for example, at the UK Data Archive. But at a machine actionable level, until recently, there hasn't been a lot of a really good methodology to handle stuff. So open digital rights language is something that's really developed in the last, I guess, 3 or 4 years and started to mature now, which gives you a model to think about how you make access work. So when someone rocks up to a site and says, I want these 3 variables and these 25 rows combined from these 2 different data sets, that's a structural problem. What you then need to think about is what level of sensitivity do these variables have that might have a risk of disclosure or that might require you to do other things, whether they're human mediated or machine mediated, before the researcher can actually get access to that data. So very briefly, ODRL is a fairly sophisticated model now where you have assets, which you might have called data sets, which have access policies, and these are structured with rules. So, in terms of rights management, permissions are things you are allowed to do, obligations are things you must do, and prohibitions are things you must not do. And those apply to different parties, as they're called. They determine the things that might happen, which may themselves have constraints. So, I mean, doing ODRL in 2 slides is quite a big challenge, but just to give you a visual fix on this, this is what an ODRL license would look like in practice. So you have the machine readable stuff at the top, and essentially what this says is for study number 2000, ONS, for example, as organisation number 55, have asserted that guest users can view the metadata, but anyone who's based in the UK can actually download the data. So this is an active area of research for us, and to be frank, is one of the things that's holding us up moving forward with the actual structural portal. That's a lot of work has been done on designing the structural aspects of this, but ODRL is still a significant. So in terms of the user experience for SERL researchers, the important thing was for us to provide a single entry point, and rather than simply throwing a large number of data sets for selection at the researcher, we conceived of this almost something we call a universal query, where a researcher can say, look, with a small number of parameters, i.e. geospatial, where is the data, temporal, to what time period does the data relate, and conceptually, what themes is this data about? If you can specify those things, you can then start to drill down into the actual data that's available, and using a combination of HBase and a knowledge graph, you can actually present linkages that are available rather than fictional linkages that might or might not be available post hoc once you've downloaded the data. So that allows you to define essentially bespoke data products, and once those are defined, they then need to go through the access conditions that are defined by ODRL, and then you backhaul that data into a virtual environment if appropriate, or you could download that data. So as an example use case that we've already worked on the kind of proof of concept platform, you know, a typical research question from an energy researcher might be, can I, you know, show average energy consumption by social class? Now this by definition is a cross-domain research question, because you're looking at socioeconomic variables here, and you're also looking at energy data variables, and you'd want to look at two demographics. So you want to see a geospatial visualization of that information as well. So the data sources for this would be smart meter energy data and household survey data, two things which traditionally would sit in completely different environments or infrastructures. So again, without going into too much technical detail, we use Apache Spark as a kind of memory-based computational framework which can process millions of records very quickly in several seconds to make this happen. Okay, so this is a concept platform which is actually just an extension of Kibana, which some of you may be familiar with, but we've actually customized this with additional classes and additional functionality. So a researcher would first, as a query, select the concepts they wanted to work with, which in this case would be picked from our thesaurus, which would be Hassett. But in terms of extension, you know, this could, in theory, be any ontology or any taxonomy. So firstly, you define the concepts that are assigned in the knowledge graph to these. You define a temporal range. You know, in this instance, you would be interested in data from the beginning to the end of 2009. In this case, we haven't chosen to select a geography, but you could select, you know, you might want to restrict results to London, something like that. So having selected that concept, those concepts and the temporal range, what the system will do then is return you things that are associated with these concepts. So what you've done is a conceptual and temporal query, and what the system returns to you is all the available variables of data sets that you can possibly use to further refine this. So, I mean, I've missed out all the steps here, but essentially the variable that you want to visualize would come from an energy data set, which has an aggregated variable already for energy consumption. The variables you want to act on are acorn category, which is a socio-economic variable. And you can define in here what the range of the, you know, what bands of that variable you're particularly interested in. So essentially what you're doing here is dragging and dropping two different variables from two different data sets to perform a particular research query. So having done that, in terms of visualizing that, those are the results you would end up with, okay, which shows you the energy consumption for the affluent range on the left-hand side and the energy consumption for the socio-economic class defined as poor on the right-hand side. Okay, so all of that needs to be driven by really quite sophisticated, complex metadata under the hood. So that is essentially what we're working on at the moment. Now, as I say, there is a lot of research we need to do over the next few months around ODRL, assigning disclosure and sensitivity type metadata to individual variables. But we hope to have that work completed by the autumn, because one of the problems here is that this is a relatively new area of research, and finding the right kind of resource to do that work is not easy. But we have identified a couple of people now who we can work with over the next few months, where we feel we can drive this forward more. So overall, once we get the ODRL problem ironed out, we expect this platform to be online by the end of the year. It has taken, you know, quite a long time on this project, because we faced a lot of quality issues with the incoming metadata, which we hadn't anticipated. But what we've tried to do here is take a completely new and fresh thinking approach to how we manage cross-disciplinary data. So I suppose the takeaway messages from this are that unification of metadata and data is really important about doing things like subsetting or bespoke data products. making sure that you assign enough conceptual or semantic metadata at the variable level is important to enable much richer discovery. It probably goes without saying that these things should be standards based. So at the moment we're working with DDI. We're exploring possibilities that are being offered by DDI, CDI with co-data in EOS at the moment, and it's essentially looking at structural data as to where is the point at where it becomes an irreducible problem. I think the logical outcome of that is thinking about data from the datum level, which gives you the best chance, in our experience of being able to do genuine kind of cross-domain research. Access model should not be understated, and in thinking about a unified access model, rights management, consent, and human-mediated access administrative workflows, that's really important. And thinking about data products rather than curated and pre-designed data sets. So those are some key key points that have emerged from our work over the last 2 or 3 years.
Fantastic, thank you, Darren. That's really
okay.
Interesting.